Welcome to SoWlful Crafts. Today I'm going to try to repair a plastic gear that lost some of its teeth in an unfair battle with another gear. So, quoting a classic song, let's get it started. This particular gear is a part of reduction gear mechanism of a paper shredder. It transfers the rotation from a motor to shredding shafts of the shredder itself. So naturally a lot of force is applied to it. One might wonder why make such an important part of a machine out of plastic in the first place, since it most definitely will be the first one to fail, considering the fact that the corresponding part that drives it is made out of metal. But I guess some questions just aren't meant to be asked. As you might have noticed, this isn't my first attempt to repair it. It actually is a second and a half, since the very first attempt failed right away. The basic idea is to recreate the worn-out part of the gear using a two-component epoxy resin. I'll briefly run through my previous unfortunate attempts to repair this gear. My experience with epoxy resin is as humble as it can get. I have some amount of molding epoxy which I got from well-known Chinese platform, and its intended scope of application is modeling something decorative. Since I had it on hand and didn't know any better, I decided to wing it with it. Yeah, I know, it's a very scientific approach. But the issue with this resin is that it remains somewhat soft and flexible after curing. Although it's not an issue for some decorative project, it surely is one in this case. So, in order to improve the stiffness and abrasion resistance of the final product, I decided to dope this resin with something, and that something was aluminum powder. But the result was disappointing to say the least. The cast came right off of the gear, leaving no trace behind it. Upon analyzing what might have been the problem, I figured that I must have miscalculated the resin hardener proportions, which turned out to be the false assumption eventually, and also left it to cure over the weekend at the shop, where it's about 2 to 5 degrees Celsius or 35-41 Fahrenheit, because it's winter outside and no one bothers to keep it warm when no one's around. For my second and the only somewhat successful attempt, I decided to use pure epoxy resin in hopes that this will help with the adhesion to the gear plastic. And everything came out pretty good, except for the fact that the epoxy remained fairly soft, and this wasn't due to miscalculation of the component proportions, it's just the property of this resin. Long story short, it lasted for about 2 to 3 hours of continuous work under moderate load, before failing in the same manner as it originally did. So the issue is clear, the only thing that is unclear is how to solve it. I went to the local hardware store in search of some hard and durable epoxy, but there actually isn't much to choose from, so I decided to try my luck with some two-component epoxy adhesive instead. Its characteristics sounded promising, although I feared that since it isn't intended for molding, its shrinkage upon curing might be unacceptable. Also, its hardness was of the question. Well, before starting to make this video, I did some experiments with it to test its hardness and shrinkage upon curing. And since you're watching this, the results were acceptable enough to proceed with my attempt. So let's go to the shop and grind this clear epoxy off to prepare the surface for what I'm hoping will be a successful attempt to repair this gear. While we're here, I'm going to make a holder for this gear, because the next step will be making a wax cast that will act as a mold that I'm going to pour epoxy in. This PVC pipe will do just great to hold molten wax while it sets. Now let's head home and cook some wax soup. It actually took me 2 tries to make a perfect cast, because the wax should be as hot as possible and shouldn't be poured too fast to fill all the teeth, as it tends to leave air cavities when coming in contact with relatively cool plastic of the gear. The tricky part is taking this cast off without breaking it, due to the fact that the teeth are at an angle. So I used a hair dryer to heat the sandwich up in hopes that this will help to loosen the grip of the wax, so to say. And it even fits perfectly. Who would have thought, huh? From now on, it's pretty much a straightforward process of mixing epoxy components and filling the mold that we made with epoxy. It's a good thing that I decided to check out the other side of this creation, since I didn't account for the viscosity of this resin. So I had to fill it from the other side as well. Okay, at this point I think I deserve a little tea break. I'll set this aside for now and let the epoxy cure. Well, I had way too much tea while anticipating the results. Let's take a look at our Frankenstein's monster. Yeah, the epoxy didn't fill everything perfectly after all. But I think I'll degrease it and fill the gaps manually with the same epoxy. Otherwise, this looks pretty promising. The hardness of the final product is great in comparison to my previous attempt with clear epoxy, but I'm starting to have doubts about whether this hardness is actually good, since the force that is applied to this gear is significant. I'm afraid that it might shatter under load. But I'll see how it will behave when I install it. I'll keep you posted on the well-being of this gear. So let's consider this project finished, for now at least. Thanks for watching. I hope that this video was at least useful, if not entertaining. If you liked what you saw, please consider liking or subscribing, or liking and subscribing. And if you didn't like this video, you can share it with a person that annoys you, just to annoy them. Take care, see you next time.